Okay, so in lesson 16, we start the topic of division with fractions. So just like all of the other operations, we're going to spend some time learning the basics. And by basics, I mean we're going to learn the different types of division problems. And we're going to use what we know about that to be able to sort of classify problems. So one of the types of division problems when it comes to division with fractions is called measurement division. An easier way to describe this, we also call this repeated subtraction. Okay, with measurement division, we know the size of each group. So in other words, the number of groups is unknown. Size of the groups is known. Very important. And then we have partitive division. Where the size of the group is the opposite. It's unknown. But the number of groups is known. And so we're going to spend some time mostly for quite a while, like the next couple of lessons, really working on repeated subtraction. So we're going to really spend some time with the measurement division problem. Today we're going to just kind of like learn about everything, but for the next few lessons, we'll really focus on sort of repeated subtraction. So again, measurement or repeated subtraction, you know the size of the groups, but the number of groups you don't know. When it comes to partitive division, or this is also called partitioning, With partitioning or partitive division, the number of groups is known, but the size of the groups is unknown. So these are actually proposed story problems. These are problems on this page on 157 are problems that other students, like previous or prior students in, I believe, Math 251 or Math 252 came up with for the division 6 1/2 divided by 1/2. So we're going to go through each one and we're going to classify them. So number one, Mary and Jim had a pizza party. After the party, there were 6 1/2 8-inch round pizzas left over. They want to split the leftovers between two of them equally. So notice between two people, which means I know the number of groups, right? It's two groups. So if I know the number of groups, well, I'll finish the question. How much pizza? So it's asking me how much pizza. I don't know, right? This would be akin to the size. So it's telling me the number of groups, right? 2. The size of the groups is what we're trying to figure out. So that must make this a partitive division. Right? That's partitive division. So what would the number sentence be? Well, I'm taking the 6 1/2 pizzas and I'm dividing it amongst two people. Okay? I'm also going to put 6.5 divided by 2. There's no units for these. right? So we have 6.5 8-inch round pizzas being split amongst 2 people. So the meaning of this number sentence, right? We want to find, obviously, half, right? If I'm splitting something amongst 2 people equally, then that means I want to find out whatever half of that thing is, right? So very important. When you want to find half of something, you're not dividing by 1/2, you're actually dividing by 2. So the student that came up with this problem, right, obviously they made that mistake where they figured, all right, if I'm sharing something between 2 people, that's the same thing as dividing by 1/2, but no, you're actually dividing by 2. Finding half of something means you're splitting that thing into 2 equal-sized groups. Next one, right? Jim has 6.5 gallons of water in a container in the refrigerator. Each day, his household drinks 2 gallons of water from the container. How many days will it take to empty the container? So think about this one. I have 6.5 gallons, right? And let's say I wanted to solve this. If I have 6.5 gallons, and every single day my household drinks 2 gallons, and I want to find out how many days that would be, I could just keep doing this, right, until I have no more water left. So this is an example, obviously, of repeated subtraction. It's saying I have, subtraction. It's saying I have 6 1/2. How many groups of 2 can I make from that? So we're still dividing by 2. However, the meaning is different, right? Given the context, I want to find out how many groups of 2 are in 6.5. Okay, pretty different. Here we were taking something, right? We were trying to find the size of one group. Here I know the size of each group. The size is 2, or 2 gallons, but I want to find the number of groups. However, right, the division sentence is the same. Just something interesting. Micah has 6.5 quarts of Boulder Cola. If she drinks half of it, how much does she drink? So that's obviously a multiplicative comparison problem, right? You would also still be finding half, right? Micah has 6.5 quarts. She drinks half of it. How much does she drink? You're finding half of 6.5. Okay, so the number sentence, however, would be like so. Half of 6.5 is half times 6.5, or 1/2 times 6.5. You might be confused, and you might ask yourself, well, what is a multiplicative comparison story problem doing on, a division lesson? You have to remember that these are proposed story problems for 6.5 divided by 1/2. In other words, a student submitted this problem and thought that this problem represented 6.5 divided by 1/2. It doesn't. So that's why it's on here. These are proposed problems. Okay, and so far, no one has it right. Sarah was planning a 6.5-mile race for charity and wanted to place water stands every 1/2 mile. How many water stands will she have to set up? Well, think about that. So I have 6.5-mile race. Every 1/2 mile, I'm going to put a stand up, right? How many water stands will she have to set up? So I could solve that by doing this, right? Every 1/2, I'm placing a new water stand. And the question is asking me, how many will I have to set up? So once I get to 0, I'm done, and I can count how many 1/2s I have, right? So obviously, this is repeated subtraction because I'm looking for the number of groups I can make, or how many 1/2s there are in 6 1/2. And this one, finally, is correct. If I want to know how many groups of 1/2 are in 6 1/2, then I can solve that by doing 6 1/2 divided by 1/2. I just wrote the same thing. I meant to write 6.5 divided by 1/2. I could also write this. Okay, so important takeaways from this page. Again, very important. Measurement division is the same thing as repeated subtraction. That's number 2 and number 4, right? I'm trying to find out the number of groups, but I know the size of each group. Okay, so in number 2, Jim had 6 1/2 gallons. The size of each group is 2 gallons. How many groups of 2 gallons can I make from that? That's I could do 6 1/2 minus 2, minus 2, minus 2, minus 2 until I get to 0. Right? Same thing with number 4. 6 1/2 mile race. After I run after 1/2 mile, I place a water stand. How many water stands will I place? Well, I could do 6 1/2 minus 1/2 minus 1/2 minus 1/2 until I get to 0. And find out how many times I subtracted 1/2, right? The number sentence, however, is 6 1/2 divided by 1/2. So I have the size, it's 1/2, and I'm looking for the number of groups, right? The other type of division is partitive, where the number of groups is known. Like I have 2 people trying to share pizza, but I want to know how much each one will get. I'm trying to figure out the size of each of those groups. Okay? Don't forget about your typical division terms, like the whole. That's obviously the 6 1/2, right? That's the dividend. The divisor, if it's a partitive division, then that means the divisor is the number of groups, right? Like this. In partitive division, the divisor, which is 2, is the number of groups. In a measurement problem or repeated subtraction problem, like number 2, the divisor is the size of the groups. Let's move on. So now we're being asked to write a different realistic story problem than the one on the previous handout. That's the previous page. That can be solved by 6 1/2 divided by 1/2. So I'm going to write a quick repeated subtraction one. How about Q is making, I should have wrote baking, cookies. Each batch calls for 1/2 teaspoon of lemonade. I should put lemon zest, but whatever. If he has 6 1/2 teaspoons of lemonade, how many batches of cookies can he make? Right, so 6 1/2 is my whole. This is the size of my group, 1/2. And I'm trying to find out the number of groups, right? How many batches of cookies? So that's repeated I'm going to abbreviate this as RS. And if I want to demonstrate that division, I can do that easily. So that's my BMU, 2 halves. This equals 1 half. And I have 6.5, right? So that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, and that's 1 half. And the size of my group is 1 half. So I'm literally just 3, 4, 5, 6, 7, 8. I should probably label this, excuse me. That's 6 and 1 half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that means he can make 13 batches of cookies. You can also use an area model. So I'm going to do an area model. I'm going to do a fancy one. You can just stop watching if you got the gist, but so this is my BMU, 6.6. Right, now I need to make 6 of those. Oops. Can't forget to show my measuring units. So that's 1/6. 3 of those would be 1 half. 3/6 is 1 half. And now I need to draw 6.5 of them. That's 1. It's a little difficult to draw because I'm running out of space. 2. 3, 4, 5, 6, and don't forget that I have a half, so we're going to split that into 3/6. Now I need to split all of these into 6, right? 1, 2, 3, 4, 5, 6. I could do that better. Halves and then thirds. And then these are all 1/6. Okay, and then remember, I'm looking for groups of a half, right? How many batches of cookies can I make, right? When each batch calls for half a teaspoon of lemonade, and my model, right? In my model here, half a teaspoon is 3/6. So let's go for it. Here's one group. Here's another group. 3, 4, 5. Right, each of these BMUs has 6, 6. So obviously I'm gonna get two batches in each group, right? So 2, 4, 6, 8, 10, 11, 12. Oops, did I do something wrong? 2, 4, 6, 8, 10, 12, 13. There we go. Right, so I still ended up with 13 batches. Okay, so that's how you would do it in an area model. We can do the linear one. If anyone requests it from me, I can draw it for you, but that's the end of lesson 16. So if you have any questions, just let me know. Otherwise, have at it. I'll see you guys on Tuesday.